Hello everyone. In today's video, I'm going to show you how to solve a projectile motion type of problem, a vertical motion type of problem, a relative motion type of problem, and finally, I will show you how to find the direction of the given vector component. So, as always, let's get started directly by giving some examples. So, as you can see in this one, this question says a ball thrown horizontally. As I always, you have to remember the keywords, okay? Horizontally from the point, a point 36 meter above the ground, strikes the ground after traveling horizontally a distance of 22 meter. With what speed was it thrown? Assuming negligible air resistance. All right. So, as always, we have to sketch a picture that depicts the situation in the problem. So this is simply the 36-meter high, whatever it could be, a building or whatever this is. Okay, this is the point, 36 meter from the ground. Now this is the ball. Okay, remember this, the ball was thrown horizontally, so it's going horizontally. It's not like a free 100% free fall, it's horizontal motion. Now when you kick this ball horizontally, eventually it's obvious that it will bend. Okay, it will bend and then it will follow such kind of trajectory, right? Such kind of trajectory. All right, and then it will end up somewhere here. Okay, somewhere here. So in this example, it's given that it will cover a horizontal distance of 22 meters. Okay, horizontal distance of 22 meters. Now this is the projectile type of motion. Let's talk about some facts about projectile motion specifically that would help us to solve this problem. Okay, so at every point in the trajectory, okay, there is the x component, which is vx. We call it vx. Okay, there is vx. Okay, there is vx. Okay, so this vx is constant, it's the same. The x component of this projectile motion is not changing, it's the same. But the vertical component is changing, okay, by increasing, okay, by increasing all the way, okay, all the way until the last impact point. So this v y's, this we can call this vy1, this y is vy2, this is vy3. That's indicating that all these velocities are different, they are increasing, but the x components are the same. As you can see, vx, 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 they are all the same, it's constant. So I can say vx is equal to constant. Okay, this is constant. This is very important point that you have to know, right? Now the y component is increasing through the whole trajectory, but it started at the beginning. At the beginning, this one, you see, v initial was 0, which is for the y. Okay, the y component, remember I told you there is x and y component each time, so the vx is still here at the beginning. Okay, but we have the y component also. That starting y component is of course 0, but since after that it will keep increasing. Okay, the y component will increase, but the vx still remains the same. Okay, this is very important point. Okay, but vy, the y component, changes. Okay, this changes. These are the key points that we have to know when we talk about a projectile motion. All right, now so the givens, let me do now the givens. After I have this fact, let me do the given. Okay, the givens are here. All right, so the y is the vertical distance, 36. I mean, the height is 36 meters. That means it's coming from up to from top to down. Okay, so that means to the bottom. So well, the final is gonna be, the y2 is gonna be 0 meters because it's gonna raise to the ground. Okay, but it was thrown from the height of the first height, which is the 36 meter. Okay, this is the 36 meter, guys. All right, excellent. Now the other important given is x. Okay, the x component, the horizontal distance is given as 22 meter. Okay, 22 meter. And then what is asked? Okay, required. Okay, what is asked in this problem? Okay, it's required that to calculate what with what speed was it thrown. That means what was the initial velocity or the initial speed of this one. Okay, the initial speed of this one. Well, I don't know. The initial speed was the horizontal, but I don't know that. But one thing I know is that's the same. The initial speed was initially this was thrown horizontally. So we are looking for the x component of the velocity. Vx is question mark. Okay, it was thrown horizontally. Remember, it was thrown horizontally. So that means we are looking for that. All right, now solution. Solution. Okay, solution. How can I solve this one? Well, I have the horizontal displacement of 22 meter because it reached 22, and then Vx. Well, I have this formula, right? Vx is equal to horizontal distance over time. Okay, I have this one. But what is the problem with this formula? Well, I have an issue here because I don't have t. I don't have t. So where I'm gonna get t if I don't have t? Well, I have to think differently now. Okay, this is projectile motion. If this is projectile motion, it has vertical and horizontal components. So both of them are independent. So let me go check the vertical, the 36, if I can use the 36 and then to find something so that it will help me to calculate my t and then go back substitute t in here. Okay, so another option, okay, or another way of looking at this problem. Okay, but I can say but, okay, but since I don't have t, but I know that delta, another formula I have, delta y is equal to, okay, u not y t, right, minus 1 over 2 gt square. Okay, how do I get this one, or where did I get this one? Remember, I'm gonna remind you something. If you remember, earlier we discussed about delta x is equal to, right, u not x, or just uxt plus half of axt square. Remember, these are equivalent. Okay, the first one is this delta y is for vertical motion. That will be the delta x is equal to, t plus 1 over axt is going to be the vertical motion. Okay, this is one of the kinematics problems, kinematics formulas. So we can turn this one into vertical motion. See, now the negative is here. Since it is vertical motion, the negative g is going to be the acceleration of this object. Okay, this object falling. Okay, now, all right, so look at this. Why I choose this one? Because I have something here. Okay, the g is known. Okay, delta y is known because I have two y's, y1 and y2. So I can substitute this one like this. Okay, y2, right, minus y1, which is delta y, V naught YT. Remember, V naught YT. What is this V naught YT? That means the initial Y component velocity of this ball is 0. Look at that. That's the key point now. You have to remember this. The initial Y component velocity of this projectile motion is 0. So the whole term, the beginning term is going to be 0. So I will have only minus 1 over 2 gt square. Okay, very good. Now, I can go ahead and then do something now. Look at this. Y2 is what? Y2 is 0. Remember, because it's gonna go to the ground, then at the ground level, just y2 is gonna be 0. Okay, so that is 0 minus, what is y1? Y1 was 36. Remember, 36 is equal to half of, right, negative half of, I'm sorry, this is 9.8 meters per second square, which is the g times t square. Okay, now look this one, right? So if I multiply both sides by negative, this negative will go to positive. That means 0 minus 36 is negative negative. I can just cancel these two negatives, okay, from both sides. That's all possible, right? So what I'm gonna do is, next I'm gonna cross multiplication because I'm looking for t. Remember, I'm looking for t. I'm gonna cross 2 times 36, which is 2 times 36, right, is equal to 9.8. Okay, let me leave the unit for now. Okay, t squared, because I know the t is just the second. So look at this. This is gonna be 2 times 36 is what? 72, right? Is equal to 9.8 t squared. Okay, so now divide both sides by 9.8. 9.8 divided by 9.8. Okay, this will cancel. Okay, now this will give me t equals to square root of, I'm gonna put this 72 over 9.8. Okay, Okay, excellent. T is equal to, if you use your calculator and then plug in this into your calculator, you will get an approximately 2.7 seconds. Bingo. Now, this is the lifesaver. Why? Because remember the beginning. The beginning, we are looking for Vx. Okay, now we have T. Okay, we have T from the vertical motion. Go ahead and plug in here. Okay, so now I can say now. Okay, I can say now. Velocity in the x direction, which is the same all the way, is x, which is the 22, right? The 22 meters. And then T, which is the one that I got from the vertical motion, zero point 0.7 seconds. Okay, Vx is equal to, if you divide this is gonna give you 8.1 meters per second approximately. So the ball was thrown initially at 8.1 meters per second in the horizontal direction. Okay, in the horizontal direction. That 8.1 meters per second will continuously going all the way to that. When rolled down a mountainside at 9 meters per second, the horizontal component of its velocity vector was 2.5, okay, meters per second. What was the angle of the mountain surface above the horizontal? Okay, now, very good. So, as always, let's create sketch a picture about the situation. Okay, so mountainside. Okay, we are talking about a mountainside, and then, well, that means basically, well, we have horizontal surface. We have horizontal surface that is like this, obviously. Okay, so when rolled down mountainside at 9 minutes, rolling down means if something has to roll down, there must be an inclined kind of plane, right? Just this is, let's say, I can consider this like the mountain, all right? If something is rolling down, I don't know whatever that is, just we don't have to worry. Okay, it's rolling down this way. Okay, it's rolling down this way, right? So that means unless and otherwise this is inclined at some angle, okay, something couldn't roll down. So okay, if something is rolling down this, so that's 9 meters per second. This I could call this one whatever, just the V. Okay, the V is equal to 9, right, meters per second. This is given. Okay, the horizontal component of its velocity. Remember now the component vectors, so if something is here between x and y, you remember that, or maybe if you don't remember, that's fine. So it has the horizontal and the vertical components. Okay, this is the horizontal component of this, which is the Vx. We can call it the x component. There is also the y component, which is the Vy. Okay, the Vy. Okay, there are two components of this vector. Okay, two components of this vector. Now, all right, so finally you are asked what was the angle of the mountain surface above the horizontal. Okay, if this is the horizontal, okay, so this is the mountain surface, so this angle is asked basically. Okay, this is, we can call this angle theta. Okay, this angle theta. Okay, now remember, now if you think about this, we can create a triangle here. Okay, a triangle here. If you just extend this vector, because it's gonna be all the way down, all the way 9 meters per second. Okay, so the horizontal component, the other horizontal component, the horizontal component Vx, this is the horizontal component, this is the vertical component. So Vx is given. Vx is given. That means 2.5 meter per second is given. Okay, so you are asked the angle. Okay, this angle. Okay, now I can redraw this one simply like a little triangle, which is this one, right? And then this one. Okay, guys, this one, and then, all right, I just can take this one simply like this. All right, let's take this. All right, so this is asked. This is given. Okay, and then this side is given. This side is given means this vertical, I mean this horizontal side is given. So now remember, the hypotenuse is given here, right? The hypotenuse of the triangle is given. Hypotenuse, okay? The hypotenuse is given. And what else is given? The adjacent, okay? The adjacent is also given. Adjacent and adjacent side, okay? The adjacent side is also given, right? Because this is the angle, and then this is the horizontal component. The horizontal component is the x component. By vector transformation, this is just the same as this. Okay, from this triangle I can have this Vx is just this Vx. Okay, so I have these two given us. Now, remember now. So basically, what I have to remember is you remember the Sakahoto. Okay, so ka to okay. This is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so we have hypotenuse and adjacent. Okay, hypotenuse and adjacent. So I have adjacent and hypotenuse. So this would be the best one. Okay, okay. Well, if we know the opposite side, which is this one, the y component, we can use any of these connections, actually any of these relations, and would get the same degree. Okay, the same angle measurement. So I would do just, okay, cosine of theta is equal to the adjacent side, okay, the adjacent side over the hypotenuse side, okay, the hypotenuse side, which means that the adjacent side is basically the Vx over the hypotenuse side is just the V, okay? So, or this, we know this one, just to remember, Vx is equal to V times cosine of theta, okay? Just you remember this one, right? Now, well, now cos theta is this one, cosine of theta is equal to, what is the adjacent side? The adjacent side is 2.5, right? 2.5, and then the hypotenuse side is just 9, okay? This is this, right? Now, if cos theta is 2.5 over 9, to find the angle, I have to use the inverse of this one. That means I have to do the cos inverse of, okay, theta is now the cos inverse of 2.5 over 9 is gonna be just my theta. I'm not asking cos theta, I'm asking to calculate the theta, which is the angle, okay? So cos inverse of 2.5 over 9, okay? So this can be calculated from your calculator if you go to this one. So cos theta is right here, right? And then above it is cos inverse. So to get to the cos inverse, I have to do just second and then hit cos inverse. So it will give me cos inverse, and then I have to write my number, which is 2.5 divided by 9, right? Divided by 9, which is this. So if I go enter, all right, so this is 73.87 degree is gonna be my angle. 73, this is 73 point just 8 approximately degree. Okay, so this is the angle. Okay, this is the angle. So basically what you have to do is you have to remember these relations, okay, and then you have to know where are the sides, where is the angle. So as I always say, if you don't translate this problem into the picture, or if you cannot make an image in your mind about the situation, it's hard to come up to this problem. So always make sure to identify where is the x component, where is the y component, where is the hypotenuse, where is the main vector, and so on and so forth. Okay, great. So let me continue to the next problem now. All right, so let's do this one again. Okay, this is very interesting, right? It's like a game, right? So let's do this. What initial velocity must a ball have when thrown upward to reach maximum height of 36 meter? Okay, very good. Now, as always, we have to create the picture. Okay, we have to understand. Okay, so this is the horizontal surface. Maybe you are on the ground. Okay, so what initial velocity must a ball have when thrown upward? Okay, the ball is thrown upward. Okay, thrown upward from this position. Okay, maybe you throw it up, and then, well, eventually it reached to the maximum height, which is in this case 36 meter, right? Y is equal to 36 meter, right? This is 36 meter. So in real life you have to think about this. What will happen when something reaches the maximum height? Well, eventually it has to come back, because there is a continuous pull of gravity. Nobody is gonna, anything cannot go like, forever. At some point, well, it has to come back again to you, right? So, but there is one thing we can say now. Okay, at maximum height, the v, which is the maximum velocity, must be 0 meter per second. Otherwise it wouldn't come back to you again. The reason why it's coming back to you is, well, it reached the maximum velocity of 0, right? Because there is continuous pull of gravity into the opposite direction. It's slowing down. As it goes up, it's slowing down. Okay, it's slowing down. And the acceleration is just the g, which is the negative 9.8 meter per second square. Okay, all right, so I know this. Well, but what was the initial velocity is the question. What was the initial velocity to get this kind of situation, to get 36 meters above the ground? Okay, this is the question. Okay, well, what I have to do is this. Well, I can say now y1 is equal to 0 because it was at the ground. I mean, at the beginning, so it's going up. So y2 will be the 36 meter. It reached 36 meter, right? And I know something. Well, the v, or the final velocity, is 0 meters per second. Okay, all right. And then I know the g, the gravity is acting here because this is vertical motion. So this is negative 9.8 meters per second square. Excellent. Now, so I have to remember those equations of uniformly accelerated motion, or the kinematic equations. So let me say the required. What is required now? That is required. So what initial velocity? Okay, what initial velocity? U is asked here. Okay, U is asked. Now let's remember solution. Let's remember all those equations. Okay, well, one of the equations was, if you remember, v square is equal to u square plus twice of a x x. You remember this one, right? This was for horizontal motion. Okay, so there is an equivalent equation for vertical motion. Okay, we can change this one simply into vertical motion. The only thing we have to change is this ax must be ay. That ay is gonna be the g, the gravity. Okay, so okay, then if that is so, my equation is gonna be v square is equal to, right, u square, right, minus twice of g y, or delta y. Okay, change of in y or just y. Okay, change of y or delta y. Okay, excellent. Now this is easy now after this. So what is v? We say v is 0. You see that? This is v is 0 because at maximum height, 0 equals to, well, u squared, the one that I'm looking for, minus twice of 9.8 meters per second square times y is just delta y2 minus y1 is 36 simply. Okay, 36 meters. Excellent. All right, now this is 0. I can, okay, let me go one more step. You can do it differently if you want to. Just y square minus, okay, what is this number? 2 times 9.8 times 36. Okay, so I can just move the whole thing to the right. Okay, move this to the left or to the right, it doesn't matter. Okay, this will be, u square is equal to 2 times 9.8 meters per second square times 36 meters. Okay, look at that. All right, because this is negative. Okay, this is negative, and I'm looking for u square. I can move the negative, the whole negative, multiply this number, and then move it to the left side, and then just it will be equal. It's positive. Okay, so now to avoid this square, I can put both of them under square root. Okay, under square root. So that means u square under square root equals to square root of this one, 2 times 9.8 meters per second square, right, times 36 meter. Okay, all right, so this is basically mean, right, u is equal to square root of twice of g times y. Okay, remember this was the formula basically. So then u equals to, if you plug in all these numbers and then check in the calculator, it will give you approximately 26.6 meters per second. Okay, so I highly encourage you, when you watch these videos, to have a calculator at hand, and then you just double check them. But just to save our time, I'm gonna give you this answer simply like this. Okay, so, all right, let's go to the last problem, which is about the relative motion. Okay, so let's read the problem first. Okay, a boat whose speed in still water is 9 meters per second. Okay, this is a boat's speed. Okay, crosses a river with a current of 7 meters per second. If the boat heads perpendicular to the current, perpendicular is very important, what is the speed of the boat relative to an observer, okay, standing on the shore as it crosses the river. Okay, very good. Now, as always, let's make some kind of a picture about the situation. So there is a river. Okay, there is a river crossing this way, right? There is a river crossing this way. All right, there is a river. Okay, so we can call this is the velocity of the river relative to the observer, because we have three things. There is a river, there is a boat, and then there is somebody observing the situation. Okay, so there are three things. Okay, so the boat will spill, okay, in the still water. So this is the boat's speed on the river. Okay, so VBR indicates that the velocity of the boat relative to the river. Okay, this is, you have to read it this way: the velocity of the boat relative to the river. So this is the velocity of the boat relative to the river is equal to 9 meters per second. Okay, this is going this way horizontally. All right, now there is um uh, this is the boat whose speed is 90 meter across the river. Okay, this is the river. The horizontal one is the river. Okay, so that's we have to be careful on this one. Okay, these are very confusing, so we have to be careful. Okay, the river is going horizontally. Okay, the river is horizontally moving. So this is the velocity of the river relative to somebody observing it, which is 7 meters per second. Okay, this is 7 meters per second horizontally. Okay, so the boat is perpendicular to the water. Perpendicular means 90 degrees. So the boat is gonna go this way. Okay, this way. It's not with the river, but it's going this way. Okay, this is going to this way. So that means this is gonna be the velocity of the boat relative to the river. Okay, the boat is going on the top of the river on the water, so that's gonna be 9 meters per second. Okay, we have to be clear about this. All right, so they are perpendicular to each other, they are at 90 degrees. So the boat is going up this way, okay, to the north, and then the river is horizontally, like this way. Both of them are perpendicular. Okay, now the question is, the observer is just observing both of them. So the velocity of the boat in reality by itself is 9 meters per second. But what is the velocity of the ball relative to the observer is the question. Okay, so the velocity of the ball relative to the observer is gonna be, remember, so the velocity of the BR, the boat relative to the river, plus the velocity of the RO, okay, the river relative to the observer. Okay, so this is very important. You have to be careful when you set up your equation. Make sure to focus on this one. Look at the two RR. This RR has to be inside. Okay, so BRR, if they cancel, BO, they give you BO, they will give you BO, right? So the RR has to be inside, not the other way around or something like that. You have to be careful about this. Now, so but since they are at 90 degree, we have to remember that we have to use the Pythagoras theorem. Okay, the Pythagoras theorem. So that is VBO square, okay, the velocity of the boat relative to observer, or is observer, okay, is equal to the velocity of the boat relative to the river square plus, right, the velocity of the river relative to the observer square. Okay, this is the Pythagoras theorem basically. So now this is equal to VBO square equals to VBR. VBR is 9 meters per second. 9 meters per second, the whole square, plus VRO, okay, the river observer, okay, velocity of the river relative to observer. Okay, you have to read them very carefully in the right way. Okay, meter per second, the whole square. Okay, nice. So just VBO, if you put both under square root, okay, this will go, and then square root of what is 9 square? 9 square is 9 times 9 is 81. 81 meter square second square, plus what is 7 square? 7 square is 49. This is 49 meter square second square. Okay, so now the next step is so easy. This is the job of the calculator. Okay, the concept is already done. So VBO is equal to, so if you add 81 and 49, you will get definitely 130, right, meter square per second square under square root. Okay, so the VO equals to, if you do your calculator simply, this is gonna be about 11.4 meter square second square. Will take out as meter per second, this one. Okay, so the velocity of the boat relative to the observer is 11.4. Remember, the velocity of the boat was 9 meters per second. That's relative to the river. Okay, so but the velocity of the boat relative to observer is 11 meters per second. So we have to be careful when we do the relative motion problems, and we have to set up the problem very carefully, and then we have to read in details. Okay, nice. So I hope you enjoyed today's video. I will see you in another video next time. Have a great day.